Circles. So now we got circles, and this is something you guys have been playing with and since you were little kids. But now we're going to get into what the actual definition of a real circle is. So if you look closely here, we got the full-fledged real definition, and that is fairly simple. Something where all it is a circle is a set of points in a plane that are all the same distance from a given point called the center. Now here, no matter how far away we go, each of the points on the outside of the circle are an equal distance away from there. Now the radius, there's not a radius listed here, but is that actual distance from the center of the circle to the outside. And no matter where it is, there's a radius here, here, if I were to draw it in, here, here, and it's always going to be the same length. Diameter is a segment that passes through the outside of the circle, the center, and then the outside of the circle again. A central angle, now this one's a little bit tougher, because a central angle is if you have points where you have a point here and a point here, and the vertex of the angle is that center point, and we'll go over that in a minute in the next slide. So, but the center angle always has to have the vertex or the letter in the middle of the angle to be the center. Now a chord is any point from on the outside of the circle to the outside of the circle that is a straight line. It's a segment. An arc is on the outside of the circle, but it's on the circle, but the outside, and it's not a straight line. So it's a part of the circle. A semicircle is just halfway around the circle, halfway. There's another term here, circumference, and that is just the distance, the outside, all the way around the circle. So that's just what we call the circumference. So if we look here, we've got a couple of things here just as examples, because some of this stuff is a little bit tricky, and some of the way it's denoted is a little bit tricky. So let's be careful here. So if it says here, name 3 radii. All I'm going to do is each of the radii has to actually start with an O or have an O in it. So let's start O, N. That's one. Another one, O, P. Remember, we're using that line up at the top to indicate it's a segment. O, M. Those are the 3 radii. So I got this taken care of. One diameter. That's going to be M, N. Try to keep it to 2 letters. M-O-N. Well, it seems we should just have the points as few as we need to. So M-O-N. Yeah, you could write it that way, but that's not the general way that it's done. So 2 chords. So now we're looking for things on the outside. Straight lines from the outside. So the easy one is M, Q. So that's a chord. Where's the other one, though? Well, once again, from here to here is an actual chord. And a chord, just by definition, is from 2 points on the outside. It's a segment. And so that is actual chord. A chord is the diameter is the largest chord. So now we got 3 central angles. Well, let's start off with P-O-M. Remember to use that angle. P-O-M. And the O has to be in the middle, remember. Then we've got P-O-N. O-N. Then we got angle M-O-N. And you could reverse these, so it's M-O-P and N-O-P and N-O-M. But the important thing is that O be in the middle. One semicircle. Well, we got actually a couple of semicircles. The semicircle that you could put down would be M, P, N. And the way we indicate when we're going in the outside of the circle is we go ahead and we put this here, a curved line over the top. By the way, extra credit here. Another one here is M, Q, N. then that would be there. So we got actually two semicircles. Two arcs less than a semicircle. So I'm looking for two arcs that are smaller than a semicircle. An example would be, well, easy one here, QM. And it's assumed that it's the quickest way around. So QM would be just from Q to M here. It would not be Q to M that way. It would be the smallest way around. Now, if I wanted to add an extra thing here, if I wanted to make it so that it was clear that I was going all the way around, I'll deal with that in a second. But another example here would be MP. But if I want to make it clear what direction I'm going, and I'm going through an extra point, I could do it this way. Q, M, P. And that would be another example. So QMP, QMP. That means it's from here all the way to there. So we got our two arcs less than a semicircle. Two arcs greater than a semicircle. Now generally you will need to have three letters for there because it's bigger, and the assumption is that if you were just write down PN, then it would be the outside measure here. It would not be through the other way around. So to make it greater than a semicircle, I would go ahead and I'd write down P, M, N. I could even do PQM or PQN, and that would work too. So that's one that's there. And now let's do one more. If I were to do QN or QMN, QMN. Again, that indicates that it's larger than a semicircle. By going ahead and making it clear you're going around this way. If I just put down QN, then I'd be going that way, but I'm not. So QMP, how did I do that? That's not right. QMP, let's fix that. I meant QMN is what I meant to put down, so let me fix that right now. So sorry about that. QMN, not QMP, because QMP is less than a full semicircle. So moving on, so those are kind of the definitions, and really just make sure for angles, the angle is always has the vertex, the central letter is going to be that one right there, the center of the circle. For segments and chords, and for radii, chords, and diameters, you have the straight line over the top. For semicircles and arcs, you've got to have that curved line over the top. Now, last part here. It's a Far Side cartoon that I always found kind of funny. This one here, if you look, you can kind of figure out. This guy here says to that guy there, I've got it too. Omar, a strange feeling like we've just been going in circles. So you can kind of look at that and see, why do you think they're going in circles? Well, maybe we'll talk about that tomorrow. But so Vikings, they may have been great explorers and conquerors, but they may have been geometrically challenged, or at least maybe logically challenged. I bet they figured it out in the end, though, because eventually they did make it to the Americas. So remember the Vikings for the little quiz tomorrow.